Hello, and welcome to my talk about Apache Pulsar's new data table abstraction. My name is David Kjerrumgaard, and I'm a developer advocate at StreamNative, the company behind Apache Pulsar. I'm also a committer on the Apache Pulsar project and formerly a principal software engineer at Splunk, where we ran Pulsar as a service internally. I have over a decade of experience in the big data and streaming space. I'm also the author of Pulsar in Action by Manning Press, which I'm proud to announce will be available in Chinese from Turing Books in 2023. I'm also the co-author of Practical Hive by A-Press. Let's talk about Pulsar's data table abstraction and how it can help you develop some interesting applications using Pulsar as a data source. So why a table abstraction? Why is this necessary? In many cases, applications want to consume data from a Pulsar topic as if it were a database table, where each new message is an update to the table. Up until now, applications use Pulsar consumers or readers to fetch all the updates from a topic and construct an internal map to retain the latest value for each key from the received messages. The table abstraction provides a standard implementation of this message consumption pattern for any given keyed topic. The TableView interface serves as an encapsulated access pattern, providing a continuously updated key value map view of the topic data. With TableView, Pulsar clients can fetch all the message updates from a topic and construct a map with the latest values of each key automatically without having to manage an internal cache or map to retain these values. Instead, the Pulsar client takes care of all the implementation details under the covers for the application developer, allowing them to focus on the business logic. As we can see here, the topic can contain multiple messages with the same key. This is true of any topic. In this case, key 1. Now the TableView treats the data as a large changelog, meaning that the newer message with the key 1 is treated like a database update command, as shown here at time t2. This new value replaces the older value, and this is reflected in the table view. So if you were to do a lookup for key 1 at time t0, you would have gotten the value of value 1. But the same lookup at time t2 would return a value of value 3. This is no different if you did an update on a database table. Depending on when you queried that piece of information, will dictate which value is returned. So how does a table view work? When you create a table view, an additional compacted topic is created for the topic behind the scenes, and this is used to feed the table view with the most recent copy of each key's data. In Pulsar, when a topic is compacted, only the most recent value associated with each key is retained and the older values are skipped. This makes reading or scanning the topic more efficient for consumers who are only interested in the most recent value for each key, which is precisely our use case. TableView leverages this built-in capability of Pulsar and puts a nice interface around it so that developers have to focus on doing this implementation themselves. For the table view, a background reader is attached to this compacted topic that consumes the messages and updates the map values internally inside the table view when new records arrive. So again, this happens transparently for the users of the table view. Pulsar has recently added this new database table abstraction called TableView, as I've alluded to earlier. I will discuss this new feature, its API, and demonstrate how to implement various SQL semantics using this table abstraction. Let's begin with the basics. Here's an example of how easy it is to create a TableView object using only a few lines of code. You need to specify only a few configuration details, such as the topic you want to view as a table and its schema type, along with the update cycle here as 2 seconds. Once you've created a TableView object, the TableView API provides 3 methods that you can use to read information from it. The first method is called get, and it acts exactly like the get command from a traditional map interface. It performs a point-in-time query from the table for the given key and returns the value associated with it, or null if no value exists. The second method, called forEach, performs the provided function against each entry in the table. The function is performed exactly once against every item in the table. It is like a table scan with an implementation across it. Is another way to think of it in SQL terms. The third method, called forEach and listen, also takes a function as an input and executes it against each item in the table. However, the method also registers a listener to the table that triggers the action to be performed every time the table is updated. This allows you to support things like continuous queries or changes, listening to these changes of the table and reacting to these events. As we shall see in the demonstration, I use this to output new values as they come in, just to show how it works. So how to use the API? How do you apply these use cases or these methods to your specific use case? So again, the get method can be used to join a table to an active stream consumer for things like enrichment. You have a slow-moving table with some metadata or enrichment data. You can query that at a point in time to update that active stream with that information. The forEach method can be used to scan the table and perform an action on the contents exactly one time. The forEach and listen method can be used to scan the table and perform a periodic or continuous scan. So depending on your use case, these are how you want to apply the API for your particular code. So let's get into some concrete examples using the use case of a stock trading platform. Okay, there we go. First, let's start by talking about the different data sets within the stock trading platform itself before we start talking about how to join them. It's best to understand exactly the semantics and schemas within these different data structures in order to know how we can join them together using the table view. Stock quotes are fed into the system as a continuous stream of records, as you might expect. They come in very quickly. They're just quotes for different securities across the stock exchange. Using the ticker symbol as the key allows us to construct a table view that contains the most recently quoted price for each ticker symbol as shown here. This table view changes quite quickly, but it is a good access point to get this information. The second data set within our stock trading application we're going to focus on today is the stock trades topic. Now this data and this information represents trades that were actually executed at a particular price on a security. So as you can see here, not only does it contain the stock ticker symbol as the key, again we use this as the key, but it also contains information about the trade itself, including the number of shares that were exchanged and the price at which the trade was executed. Now this information comes in and we're going to feed it through what's called a stock stats calculator. This is used to calculate daily statistics of a security itself, to compute values such as the daily high, the daily low, or the daily trading volume. This is going to be continuously fed as a new record comes in for Oracle, as shown here, for example. We will update these values accordingly. So the trading price might change, the daily trade value will change accordingly. This is the other part of this equation, right? So the previous slide, we saw that we were computing these stock statistics as trades come in. The stream processor reads the individual stock trades and uses that information to calculate the statistics that we discussed previously, such as daily trade volume and daily high and low prices. It simulates an update of an existing record by reading the previous value out of the table view and updating the information with the stock trade details. Using the ticker symbol as the key allows us to construct a table view that contains the most recent statistics for each ticker symbol. So as you saw in the previous slide, we were computing these values and outputting them to this particular stock statistics schema here. Again, the key is your ticker symbol, but now we've enriched this metadata, and we can still apply a table view to the stock stats topic to do lookups at point in time. This again contains the most recent statistics for each ticker symbol. Now let's look at the stock positions topic. When a stock trade is executed, the respective account holder's stock position information is updated in the stock position stream as shown here. A processor simulates an update of the existing record by reading the previous value out of the table view and updating that information with the stock trade details. For instance, we can see that the account had 100 shares of Google at one point in time, but those holdings increased to 200 later on as a result of a successful buy order of the stock. So as we came in before, we had 900. Stock trades came in, we joined the two together using table views we shall see, and our new position resulted in being 1,000. We also compute your average purchase price as shown here. Using the ticker symbol as a key allows us to construct a table view that holds the most recent holdings information for each ticker symbol. So you can again scan this information and do a lookup in real time for each individual account, rather than having to go back in time and recalculate this by storing all the different stock trades and then recalculating this value over and over again. Now that we've examined the topic data that we will be using in this stock trading platform, I want to introduce some common patterns for using Pulsar's new table view object and frame them in the context of traditional SQL database table semantics. So the first usage pattern is to join a stream to a table view. For data enrichment purposes, we can use the lookup capabilities on a table view to augment or enrich a streaming data set. Again, this is done using the get command that we discussed in the TableView API. In this case, we can join the stock positions table to the stock quote stream to present the end user a real-time update on the value and performance of their stock positions. Again, for example, this individual who now owns 1,000 shares of Google might want to know exactly what the value of his position is and whether his percentage in loss or gain on this particular security trade. This command is the equivalent of left joining a stream to a table in SQL as shown here. This is logically equivalent to this type of semantics. Here is the code that implements this pattern inside our stock trading platform. I want to highlight some of the code I will be demonstrating here. First, we create a table view against the slowly changing stock position topic that holds the stock positions for a given account. So again, this is going to have a much smaller data set. You're going to have one or two or a handful of different positions in your portfolio. Then we subscribe to the fast-moving stock quote topic, which contains all the stock quotes for all the different stocks across the universe. Inside the message listener associated with this consumer, we use the table view we created earlier to check to see if the user currently holds a position in this particular security that we just received the quote from. If he does not, we will just skip this logic because we're not interested in this particular security. However, if we are, we can quickly take the information from the table which we had earlier, again our table, and join it with the message values. So again, the position is our quantity, our purchase price, and the message.get value here shows us getting access data from the stream itself. And we're able to join these two together. Again, as if you do a SQL query, you have access to all those different fields of both tables, and we calculate the value as shown here. And we will demonstrate this later in the code demonstration part of this talk. Another option you have when using TableView is to join multiple tables to one another. Now, in our stock trading platform, we provide the user with a summary page for each security that combines the most recently quoted price alongside the various daily statistics for the security, such as trade volume and daily high and low that we talked about earlier. In this particular case, this is equivalent to a left joining of one table to another. So we're going to take our stock quotes. If somebody wants to go and look at interested in a position, they want to see the current price as well as all the daily statistics that we've computed thus far. The result is merging data. We can now display data from the stock quote and the stock stats table in a single frame, in a single view by joining these two tables together. Let's take a look at the code that implements this pattern. And again, I want to highlight some of the code I will be demonstrating here later. First, notice the creation of two different TableView objects. The first is on the stock quote topic, which creates a continuously updated map of the latest stock quotes. The second is a stock statistics map. This creates an updated map of the latest stats for every stock. Now, when a user wants to view some information about one or more stocks, we want to present the information from both tables for that security. Again, for example, Oracle. We will want to present a view to the user that combines this information from both tables from the given symbol. So we do this here by doing the for each on the stock quote table, since this is going to trigger the event most often. Every time a new stock quote comes in, we're going to do a cross join here on the stock stats table and retrieve this information, again doing a get. This is going to be another, so we're using the for each and the get here in both cases to do the augmentation. Again, as long as there's statistics computed, we're able to just join these values together with the quote and the stats using information from both tables to generate some output. So again, they're both accessible fields. All the fields from both tables are accessible in this particular usage pattern. Last but not least is the wish to view a continuously table view joins. So in the previous slide, we were doing a for each, which, as we mentioned before, is a single one-time pass through the table. In this particular use case, after a trade, you may want to update the user's user interface to reflect their new positions, including potential new securities or drop securities from closed out positions. Joining a slowly changing table with a fast changing data table here of the stock positions versus the stock quotes will achieve just that. As we can see here, we're joining again on the same key, and we're able to grab the quote from the quote table and join it with the user's current position table and calculate a percentage gain as shown here. This is the logic equivalent of doing a left join from one table to another and joining on the same symbols. Let's look at some code that implements this particular pattern here, and let me highlight some of the things that I'm going to be demonstrating later on. First, notice the creation of a table view on the stock position topic. This creates a continuously updated map of the stock positions within our portfolio, like we did in our first piece of code. Next, notice the use of the for each and listen method shown here. This registers a listener for the stock position topic and will trigger the recalculation of the net gain for your position whenever there is a change in your positions, whether you execute a buy or a sell. So again, as you execute trades and this information is updated, at this point you again do a lookup on the stock quotes to get that information that existed previously. We do not highlight that here. And if it comes in, we're continuously listening now, and if we have a quote coming back, again, we can join these two data sets together. So as you execute a trade, immediately you can retrieve this information and update your user interface, and it continues to listen and will only execute for each new trade that comes in. So you are notified of every changes immediately. Now that I've highlighted some of the implementation details, let's see a demonstration of these patterns in action. Okay, so let's take a look at the example code to demonstrate the table view in greater detail. First, I want to point out again that we've downloaded this code that's publicly available from the GitHub repo shown here. The first step is to open up the code. We've cloned it here, and there's a README, and the instructions are very detailed. It assumes that you are doing a Pulsar standalone cluster and having that running locally on your desktop. If you want to change the Pulsar cluster you're using, you simply need to change the broker URL in this Pulsar client aware class. But as you can see, we're going to use localhost. Now the first part of the process is to start generating the data. So let's go ahead and run this command here, maven compile execute java generate data. This will start a thread that generates both stock symbol quota, stock quote tables, and data, as well as stock trays, and simulate the stock trays. This information, these classes are here in the generators section of the code, and I won't get into it in this section, but it's there for you to use. Let's go ahead and start this command, and we should see it start running, and it's going to continuously run in the background. You can see here it's continuing to run. We've also set up two separate classes that you can use to monitor the data coming into the quotes, stock quotes table and the stock trades table respectively. I've set up Java programs for that. We'll go ahead and start these here to monitor the quotes. First, because the quotes will be your fast moving data sets. You can see here that there's different ticker symbols and so on and so forth. We'll stop it for a second. We've configured it to have a handful of symbols, approximately 8. Each quote coming in real time, different quoted prices. So all this data contains is a symbol and the ticker price. And so that information is moving very quickly. Next, we'll monitor the trade topic. We run this command here that will generate the output showing us what data is being pushed through the stock trades. Pause this here shortly to see that it is a different scheme. We have a stock trade. Again, a ticker symbol, a lot size of how many shares were exchanged, and the price at which it was executed at. So this information is constantly running in the background. These two processes simply just subscribe to this topic and return the information. So you can see that data is constantly flowing through the system at any point in time. Next, let's get into running the actual execution of the TableView code itself. So the first demonstration class is this of joining a stream to a stock position table. We discussed this earlier in the slides, but I want to bring it up again here. So as you can see, there are two different topics, a stock quote and a stock positions. We're doing a join command where we have a new table view across the stock position. This is again where we're subscribing to the stock quote topic, which is a fast moving command. And if for every sticker symbol that comes in, we do a cross lookup into our table view of our individual stock positions to see if we are interested in that stock sticker, i.e. we actually hold a position in that particular stock. If so, indicated by checking for false or not, then we generate some values and calculate real-time data based on that. Once we're done, either way, we acknowledge messages and we continue. So this is the joining of a stream to a table. So let's go ahead and execute this command here. Again, from the README file, this is done by executing demo1 command. So let's go ahead and see this information come through. Right, so as you can see, a lot of quotes are coming in and we're updating this data in real time. Let's pause it here to see. It's showing you that the last trade when it was occurred, reflecting your purchase price, the number of shares that you have, and representing your calculated net gain or loss for every individual share. So again, for example, AMD being back to back, this is a common use case. There were two different quotes. The price is traded, right? It went down 7 cents, and so it was reflected in our net gain there. For some reason, why that's negative. Next, let's look at the second use case, which was joining of two separate tables together. So stock position table to the stock quote table. Again, we're using the stock quote topic and stock position topics. As we saw in the demonstration, we're creating two separate tables, a stock quote table using the table view and a stock position using the table view. We're going to join the stock position table with a for each and listen command. And again, if there's a symbol is there, if we find the quote within the table for every individual stock position, we're listening. So every time in our stock position a change occurs, then we're going to join it to the stock quote and update our positions based on our last trade and purchases price. So let's go ahead and run this command, and this can be run using demo 3. So let's go ahead and run this information. And so we can see that this information is you can see periodically this table is updating as a trade executes, and only then, so we're constantly listening. This is a continuous query. We do not have to run a command over and over again to see this information. So as a trade that we're interested in occurs, as our particular account executes a trade, as indicated here in the stock trade symbol related to us, then it's going to update this information. So it was last traded. We decreased our shares, for example. We sold some shares, and so that reflects our new position and our new net gain or loss based on these values. We've traded some Apple shares from our account. Looks like we purchased some shares. Now it increased our account from previously what we had from Apple, where we had 433. We sold some as well. So again, that's all reflected in these trades. It's an uptime continuous query. Last but not least is the second demonstration, where we're joining a quote table to a stock stats command. And this is going to be here. So again, the code is in this particular class. Stock quote table join stock stats table. Again, we're going to have two different topics: stock quotes, and stock stats. We create two separate tables, one for stock quotes, one for stock stats. And then we do a for each, which is going to be a single pass through the stock quote table. And we're going to, for every quote that we get within our particular positions, we're going to get the statistics and demonstrate them one time and join the values together as well. And this can be executed using this command. Now, this is a single pass, so this would be something you'd execute if you're to load up a web page and you wanted to display this information one time. Then this occurs and it's going to pass through one time. So again, we're based on stock quotes and stock positions and stock stats. So this was a single pass, right? At that particular point in time, this was the current price for Netflix, its daily high, its daily low, based on our simulation thus far, and how many shares have traded hands during this point in time. You can see that this data does not move. There's no changes to it because it's a single pass. But you can wrap this individual code in a thread that executes periodically and have it execute again. I will simulate that by running the demonstration again. And again, it's a point in time calculation. And we should see, for example, for Netflix, the number of shares has changed. The quote should be different. The daily high and low may or may not have changed, depending on where we're operating. Again, here you can see the quote is now different. The volume of shares has changed, and there's a new timestamp on when this data was calculated. So this is a point in time query. It's a single scan, joining those two tables together. That concludes our demonstration of the code. In summary, Pulsar's new table API provides a database table abstraction on top of Pulsar topic data. I demonstrated how it can be used to emulate SQL joins with streams or table views. I demonstrated how to join streams to table views and table views to other table views. Thank you for attending my talk. Please scan the QR code to learn more about Apache Pulsar, and as always, please visit the GitHub repo shown here if you want to explore the code more yourself. If you enjoyed this talk and want to stay up to date on the latest news about Apache Pulsar, please follow me on Twitter and LinkedIn. You can find more Pulsar examples in my GitHub repo as well, including all the example code for my book, Pulsar in Action. Thank you so much.